So, for example, if a vehicle is rolling by, okay, and I have a sensor over here, a set of sensors over here, from these measurements, I would like to recover the source signal. Okay, the source, the signal, the input signal at the source. And I would like to be able to tell where the source signal is and what it is. Okay, so this is for amplification of input signal. So we recover the location and the source signal themselves. So that is done by an inverse model. Now I'm going to show this cartoon to tell you how we use this inverse model for source localization, meaning figuring out where the source signal is. So in this cartoon, let's imagine we have this city with 4 buildings, and let's say there's a source signal here. Okay, something happened here, and we can have sensor reading at these 2 locations. So the problem is to say, suppose we have these 2 sensor locations in the data from these 2 sensor locations. Can we figure out where the source is and what signal it is? Okay, so this cartoon will show you how to do that. So what we do is we have forward models that show you the mapping from a input to all these different outputs. So that's a forward model from one source to many outputs. Okay, and then to get the model from many sources to that output. So if we reverse the sensor and actuator locations, we have a distributable model. So this model will tell us if the input is at any of these locations, how the dynamics between the input at each of these locations to the sensor located there. So that's a reciprocal model. Now for the second sensor location, we have a forward model. So if the source is here, we can have a forward model that goes to all these different sensor locations, and then we do a reciprocal operation and get the reciprocal models from all these possible source locations to that sensor. Okay, so that's the only information we need are 2 forward models. Okay, that's one forward model, and that's the second forward model. That's all. Once we have these 2 forward models, we can just do a transport operation and get the reciprocal model. The reciprocal are derived from the forward model, and now we're going to use it for source localization. And this is how it's done. Suppose we want to find out if this is where the source is. Okay, what we do is we have a mapping from here to here. So we do an inverse model to figure out if this is a sensor reading, what should the source signal be if the source location is here. Then we do a forward model from this to here. And this model is one of those models for many possible source to a single sensor. So that's a reciprocal model. The reciprocal model is used to figure out what the sensor 2 should read. And then we compare what this model says, what the signal should be at sensor 2 versus what we measure as sensor 2. In this case, in this example, because this is not where the source was, there will be no match. Okay, what we compute here would not match what we measure here. because this is a wrong source location. And then we go to the next candidate. For example, this location here. We have the inverse model to tell us what the source signal should be if the source is here, based on the sensor measurement here. And then we have the model that tells us what the sensor should be if that is a source signal at this location. And then we compare what the sensor reading here versus what the sensor, or the computer signal here versus what the measured signal here. And in this case, in this example, because this is the correct source location, we will find a match. Okay, so by doing this procedure, we can pinpoint where the source location is. Furthermore, once we know the source location, we will use the inverse model from this sensor reading. We can recover the source signal itself. Okay, so not only we know where the source is, we can also recover the source signal itself. So what I showed you is a two-step guess and check kind of procedure. And that actually is only to illustrate the idea, the concept of this technique. But in fact, mathematically, we can combine the two steps into one step and have a single model for purpose of source location determination. So the two-step process can be combined. The two I explained to you just before, just to show the idea. Actually, mathematically, they can be combined into one step. So the end result is a very fast algorithm for source localization and source signal recovery. Okay, so summary, the three types of model. The forward model is a typical input-output model that you normally see. The reciprocal model can be derived from the forward model, and it tells you the dynamics of the input-output locations where the location are switched. So the input location become an output location become input location. They will switch around, and you can get that dynamics from the dynamics of forward model. And this reciprocal model is important because you don't want to identify the reciprocal model. You don't want to identify a mapping that has millions input to one output. That's impractical to identify. But we can identify a one input to a million outputs and then reciprocate that model and get the 1 million input to one output model. So that's why the reciprocal model is very important. And then the third model, the reciprocal model is also important because you want to use it to model a moving source, okay, response due to a moving source. That we have to use the reciprocal model for that. And then finally, we have the inverse model. The inverse model is a model that recovers the input signal given the output signal. And I have not gone over the details, but we have developed techniques and methods to generate the forward model, reciprocal model, inverse model. There are many techniques, many different approaches, and we have worked out a number of these techniques over the last few years. And this focus is on acoustic and seismic signal propagation. So if you have an explosion, for example, in the air, that's an acoustic event. If an earthquake, that's a seismic event. So we develop these models so that we can we use these models so that we have, instead of using the supercomputer model to do everything, which will be extremely time consuming, by these models of the supercomputer model, we can take advantage of the benefits of the supercomputer model without having to pay for the time and the resources required to run those supercomputer models. I will give this talk again tomorrow. So, your questions
Okay,
that you
you
can
have
ask.
questions? No questions? We take 10 minutes. Okay. 好，我们继续10分钟吧。对。